6 is called Properties of Kites and Trapezoids. So we're just going to split it one day. First day today, we're going to do kites. Second day tomorrow, we're going to do trapezoids. So let's first talk about what is the definition of a kite. Okay? Why are kites and trapezoids separate from the other three that we just talked about? Why? Because they are not parallelograms. Okay, parallelograms have opposite sides parallel. Kites and trapezoids do not have both pairs of opposite sides parallel. Okay, so a kite is going to have two pairs of congruent, consecutive, and we'll abbreviate it, CONS, sides, consecutive sides. So one right after another. So we're going to draw a little kite here. So we're going to have this consecutive side and this consecutive side. We'll put tick marks. And then we're going to have another pair of congruent consecutive sides, and we'll put double ticks on them. Okay? Let's label this one A, B, C, D. Okay? And a kite, probably when you were little, you went to the beach with your parents and you flew something, had a little string on the end, a couple little bows, right? Got some nice wind, you flew your kite, right? And basically, in, you know, how it was kind of plastic on one side, how did it keep its shape? Yeah, you used framing, like little sticks, okay? So if we connect B to D and A to C, those are like your supports. Obviously, they're your diagonals. They're your supports holding your kite in the proper shape, okay? So there are two theorems about kites. The first one, and let me read it to you word for word. If you look it up in the book, it's going to say, if a quadrilateral is a kite, then its diagonals are perpendicular. Okay, so the first theorem has to do with those diagonals that we just drew. So if we draw a kite, draw this one a little bit smaller, okay, and we draw in the diagonals. Oops. This theorem says that those diagonals are perpendicular. So I'm going to put a little box in there at one of those four angles that it creates. Doesn't matter which one of the four, but just put a little box in there somewhere. And if the vertices are labeled A, B, C, and D, that's a D, not a P, you might see a statement like AC is perpendicular to BD. Okay, that little upside down capital T, that's our perpendicular symbol. And, or it could say something like it's 90 degrees, or it could use the word right angles. Okay, all of those mean the same thing. All right, you guys ready for the second theorem? Yes, yes we are. All right, here's what it says. It says, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Okay? So if we have a kite, and I'm going to draw this one a little bit smaller as well, where we have two pairs of consecutive sides congruent, and we didn't put the tick marks up here, sorry. And if we labeled it, again, A, B, C, D, you're going to have exactly one pair of consecutive, or not consecutive, exactly one pair of opposite angles. Okay? Anybody want to guess which pair? And they have to be opposite from each other. Do you know?
Well, D.
D and B, yes. So this one, good guess. This angle and this angle. Angle B is going to be congruent to angle D. And that's the exactly one pair. And we do need to point out that angle A is absolutely not, congruent. So put a big slash through the congruent symbol. Not congruent to angle C. All right, I'm going to move this up. You'll see it in just a second. There it is. All right, example number 1. So we're going to look at a kite. I'm going to draw it sideways here. So here's a kite. We'll call this one A, B, C, and D again. And I'm going to give you some information. Given that it's definitely a kite, so I'm going to tell you it's a kite. I'm going to name it A, B, C, D. And the measure of angle DAB is going to be equal to 54 degrees. And the measure of angle CDF is going to be equal to 52 degrees. We're going to be asked to find a couple things. First, we want to find the measure of angle BCD and find the measure of angle ABC. All right, so once you have it copied down, then you want to take all the given information and you want to do what with it? How about, yes, label it. Okay, first of all, you know it's a kite. So go ahead and mark these 2 consecutive sides congruent and these 2 consecutive sides congruent. On a kite, it's going to be obvious which two pairs of consecutive sides are going to be congruent. Like this is way longer than this, so don't mark those congruent. Okay? All right, then you want to take this statement, angle DAB is 54 degrees. So here's D, here's A, here's B. So we're talking about this angle right here, the whole thing, and it's 54 degrees. Then we've got a second statement which says the measure of angle CDF is 52 degrees. So we come over to our figure and we find CD, where's the F? So we're going to have to draw it in. So let's draw some diagonals. Okay, and make that intersection point from those 2 diagonals. We're going to call it F. So CDF, that means this angle right here is 52 degrees. All right, we need to find angle BCD and we need to find angle ABC. Okay, so once we draw in those 2 diagonals, it takes that kite and does what to it? Split it in half, and then created these 4 shapes. What are those 4 shapes in there? Triangles. It creates these 4 triangles. You guys see that? Okay. So, triangles, we know, have how many degrees total? Did somebody say 190, really? Ouch. Okay. So, first, let's start, and we know that the figure, the whole figure, is how many degrees, because it's 4 sides. A quadrilateral has how many degrees? Triangle has 180. What does a quadrilateral have? 360. So, okay, probably going to need that information. Okay, So first, let's figure out angle BCD, okay? So come over here and find your B, find your C, find your D. That means we want this angle right here. So I'm going to put a question mark, or you can put an X, or whatever variable you like, right? Okay. So this angle is part of a triangle. You guys see the triangle? This triangle with this side BC, this triangle side BD, and this triangle CD. And we know this angle right here, and we happen to know that this side is congruent to this side, which makes it a what kind of triangle? Isosceles. You guys see the isosceles triangle in there? Okay. On an isosceles triangle, if these two sides are congruent, then the two base angles are what? Congruent as well. The angles opposite them are congruent. So if this one's 52, what's this angle over here? 52. Okay. So on this triangle, we've got 1, 2 of the 3 angles. So we're going to add the 52 plus the 52, which gets us 104 degrees. To get this angle, what are we going to do with the 104? Subtract it from 180. So start with 180, subtract the 104. What's left? I got 76 degrees. Okay? That is the measure of which one? B, C, D. That's our first answer. And we can write it up here on the figure because we might need it. So 76 degrees. Okay, now for the last part, we need the measure of angle ABC. So here's A, here's B, here's C. The only part we're missing is this part right here. So I'm going to put a little X right there. And if I come over to opposite it, this one is also X, right? Because those are going to be the same measure. You guys see that? If this is 52 and this is 52, if these two opposite angles are congruent, then 52 and 52, X and X. So we know this angle, we know this angle because they gave it to us. We know this one is X plus 52, and we know this one is X plus 52. And the quadrilateral, the whole figure, is equal to how many degrees? 360. So we're going to say, let's start with this angle right here, the X plus 52 plus the 76 that we just found plus another X plus 52 plus the 54 that we were given should be equal to a total in a quadrilateral of 360 degrees. Okay? So we dealt with the triangle. Now we're looking at the whole figure, the quadrilateral. Okay? Now it's just your basic pre-algebra kind of problem, right? You've got some variables, combine them. A 1x and a 1x is how many x's? 2x. And if you have a calculator, you can combine the 52, the 76, the 52, the 54. I got 234. So you can check that on your calculator if you want. Make sure I'm doing it right. Okay. Then we just need to do inverse operations till we get that x by itself. So subtract the 234. So 2x is 126. Divide both sides by 2. I got x is 63. Okay? That means that back up here on the diagram, this x right here is 63. And this x right here is 63 degrees. So we have everything, all of our angles are measured, right? Go back to the question, which was, what is ABC? So ABC is this whole angle right here. So is my answer 63? No, I have to add the 63 and the 52. So the measure of angle ABC is equal to 63. We move it up a little bit, plus 52 for a total